All right, y'all, this is note card 20. It's called acceleration. Let's see what it says. It says acceleration is the instantaneous rate of change of velocity. It tells us how quickly the body speeds up or slow down, or how fast the velocity is changing with respect to time. So it tells us here that the second derivative of position, or the first derivative of velocity, equals acceleration. So you want to think about these things a little bit. Okay. We think of s of t or x of t as the position function. Okay. If we take the derivative of position, that's the velocity function. Or if we take the derivative of velocity, that's acceleration. So in each case, to go down to the next one, we have to take derivatives. All right. Now the note card does tell us one more thing that we need to remember. Okay, it says positive acceleration is pushing a person or object, while negative acceleration is pulling a person or object. All right, and then this next part's really important. Like a car, okay, if you think about it in terms of a car or a vehicle, a particle's speed is increasing when the signs of acceleration and velocity are either both positive or both negative. So when the signs of v of t and a of t are the same, a particle's speed is decreasing when the signs of acceleration and velocity are opposite. One is positive and the other is negative. Okay? So when the signs of v of t and a of t are different. Okay, so let's do some practice problems here. All right, an object for positive time is moving along the y-axis. So if you want to think about this, a particle is moving up and down the y-axis, okay? So that its position, s of t, measured in meters, is given by this function, where t is measured in seconds. So if we want to think about the graph, on my graph here, this would be position measured in meters and time measured in seconds. Okay, and this is moving along the y-axis, so it's moving up and down. Okay, so it says during what intervals of time is the object moving, this shouldn't say right, it should say moving up. All right, during what intervals of time is the object moving up? Well, we think of going up as in the positive direction. All right, so this is going to happen when the velocity is positive. So we want to find the times when v of t is greater than 0. So let's first figure out what the equation of the velocity function is. Okay. Well, velocity is the derivative of the position. So let's find the derivative of this thing. So the derivative would be 3t squared minus 18t plus 24. And before we can find when it's greater than 0, we have to figure out when is it 0. Okay, when is it stopped? When is the particle stopped? So let's do some factoring, just like we did before. Take out a 3. Okay, and then factor that quadratic some more. All right, the only way I can get negative 6 and positive 8, I would have to have a minus 4 and a minus 2. Okay, so if I solve that, I'm going to get two answers, 2 and 4. These are the times when the particle is momentarily stopped. When it's momentarily stopped. Now let's make a number line. Time usually starts at 0, and time's going to go on forever. We're going to put these two values on the number line. And I'm going to put a dot there. That's where the particle is actually stopped. And let's figure out the signs of velocity. Okay. So let's pick a test value. Maybe pick 5 here. I pick a number bigger than 4. If I put 5 in to my velocity equation, you could do it in the factored form. It's a little bit easier. 5 minus 4 is positive. 5 minus 2 is positive. 3 times a positive times a positive. It's positive there, which means the particle is moving up. Now pick a number between 2 and 4, maybe like 3. 3 minus 4 is negative. 3 minus 2 is positive. So a positive times a negative times a positive, that's going to be negative. That means over this time interval, the particle is moving down. And then pick a number between 0 and 2, maybe like 1. 1 minus 4, that's negative. 1 minus 2, that's negative. 3 times a negative times another negative would be positive. So therefore, the particle is moving up. Okay. So let's answer the question. During what intervals of time is the object moving up, and justify? So we can say that the particle is moving up on t equals the time intervals between 0 and 2 seconds. And we will not include the 2 because at 2 the particle stopped. And from 4 all the way out to infinity. It'll keep going up forever after that because the velocity is greater than 0. So I answered the question and I gave a justification. Now let's do the second part of this question. It says, find the velocity of the object when the acceleration is 0. Okay, so it's asking me to find v when a equals 0. That's what the question is asking me to do. Before I can do that, I need to figure out what the equation of acceleration is. So let's figure out what a of t is. Well, what's a of t? A of t is the derivative of velocity. So here was my velocity function. Let's take the next derivative. So the derivative of 3t squared is 6t. The derivative of negative 18t is negative 18. The derivative of that piece will just be 0. Okay. So I need to set that equal to 0 to figure out when is the acceleration 0. So if I just solve this, add 18 to both sides, and then divide through by 6. Okay, so at time equals, what is 18 divided by 6? It's 3. At t equals 3, the acceleration is 0. In other words, a of 3 would equal 0. That's not what the question's asking. I need to find the velocity when acceleration equals 0. So the acceleration is 0 when the time is 3. So now I have to plug in that 3 back to the velocity equation. So now let's figure out what v of 3 is. Okay. Well, here's a factored form. Okay. I could plug it in here if I wanted to. It's just a little bit harder. This one's easier. So that means everywhere I see a t, I can plug in a 3. Okay, I just did it from the factored form. So that would be 3. 3 minus 4 is negative 1. 3 minus 2 is positive 1. 3 times 1 is 3, times negative 1 is negative 3. And the units there, since it's a velocity, this would be meters per second. Now let's do part C. It said, is the speed of the object increasing or decreasing at this time? Well, what do you know about the velocity at that time? What's the velocity of 2.3? I could plug 2.3 into here, but that's not really important. Okay, I know from my number line at 2.3, 2.3 is a number in between this time interval. I already know that the velocity is negative there. So if I plugged in 2.3, I would get a negative answer. Okay. So I know that's negative. What about the acceleration at 2.3? Okay. Well, if I plug 2.3 into here, okay, 6 times 2.3 minus 18, 6 times 2 is 12, 6 times 0.3 is 1.8, so that's 13.8 minus 18. All right, if I subtract those, it's negative 4.2, which is also negative. And that would be meters per second per second. So at 2.3 seconds, the acceleration is negative, and the velocity is also negative. So they have the same signs, they're both negative. If they have the same signs, then that means that the object is actually speeding up. Okay, because it says up here in our notes that when the signs of velocity and acceleration are the same, the object speed is increasing. So this object is speeding up. All right. Now here it finds it. Question D says find the average acceleration. Okay. So I want to find the average rate of change. But I want my units to be of acceleration. So when I'm done with this, I want my units to be in terms of acceleration. Well, what are my units of acceleration? Meters per second per second. Okay, so let's treat this like a long fraction. Okay. If I'm going to find an average, that means I would want to find the slope of the secant line of the velocity function. Okay. Well, which function is measured in meters per second? Well, that's velocity. So average acceleration means the change in velocity over the change in time. So I have to do v of 3 minus v of 1. That would be how much my velocity is changing over that time period over the change in time, 3 minus 1. Well, we already figured out what v of 3 was up here. It's negative 3. So I can plug that in right here. I don't know what v of 1 is yet. I know it's going to be positive, but I don't know what the actual value is yet. So if I wanted to figure out v of 1, okay, I could plug in 1 there into the factored form or the original form. Okay, this time let's just plug it into the original form. So 3 times 1 squared minus 18 times 1 plus 24. 1 squared is 1, times 3 is 3. 18 times 1 is 18. So if I simplify that, it looks like I'm going to get 9. 3 plus 24 is 27. 27 minus 18 is 9. So that would be in terms of 9 meters per second. So now let's plug in all these numbers. Okay. V of 3 was negative 3 minus V of 1 we just found was 9 all over 3 minus 1. Negative 3 minus 9 is negative 12. 3 minus 1 is 2. Negative 12 divided by 2 is negative 6 meters per second per second. That is the average acceleration between time 1 and time 3. Again, if they're asking for average acceleration, you need to use change in velocity over change in time. It's a slope. It's a slope of a secant line. So the average acceleration is the slope of the secant line to the velocity graph. All right. Another example problem coming up. So this next problem. For times between 0 and 7, a particle moves along a horizontal line. Okay, so particle starts somewhere and it goes right and it goes left. All right. It gives us the position function. Okay, and the units of that position function, we have meters on one axis and seconds on the other axis. So position here in meters and time in seconds. Okay. So part A, find the average velocity, okay, during the first 2 seconds. So if I want to find average velocity, okay, that would be the slope of the secant line of the position function. So to get average velocity, we need to do change in position over change in time. And that's why our units are going to work out. Change in position is measured in meters. Change in time is measured in seconds. So I'm trying to find the average velocity over the first 2 seconds. So that's between times 0 and 2. So here, I would have to take s of 2 minus s of 0 over 2 minus 0. So to be able to figure this out, I need to figure out what s of 2 and s of 0 is. So first, let's figure out what s of 2 is. Everywhere I see a t, I'm going to plug in 2. So 3/4 times 2 to the 4th minus 4 times 2 to the 3rd plus 6 times 2 squared. If I simplify, 2 to the 4th is 16, and 16 divided by 4 is 4 times the 3 is 12. 2 cubed is 8 times 4 is 32. 2 squared is 4 times 6 is 24. Okay, so 12 plus 24 is 36, minus 32 is 4. All right, if I plug in 0, 0 to the 4th, that's 0, that term's gone. 0 cubed is 0, that term's gone. 0 squared is 0, that term's gone. So s of 0 would just be 0. The position of the particle at time 0 is 0. All right, so if we plug in these numbers, s of 2 equaled 4, minus s of 0 we said was 0. 4 minus 0 is 4, 2 minus 0 is 2, 4 divided by 2 is 2. So 2 meters per second is my average velocity. Okay, part B. It says find the instantaneous velocity. So this is an instantaneous rate of change at t equals 3. So I want to find the instantaneous velocity. I'm asked for v of 3. Instantaneous rate of change would be the instantaneous rate of change to the position function. All right, so that's v of 3, which also means s prime of 3. So before I can find s prime of 3, I need to figure out what the velocity equation is. So I have to take the derivative of the position function. Okay. So I take 3/4 times 4. The 4's knock out, so that would be 3t cubed. Okay. The derivative of this term would be negative 12t squared plus the derivative of this term would simply be 12t. All right. So I'm asked for v of 3. Everywhere I see a t, I'm going to plug in 3. So 3 times 3 cubed minus 12 times 3 squared plus 12 times 3. All right, 3 cubed is 27 times another 3 is 81. 3 squared is 9 times 12 is 108, so minus 108. 12 times 3 is 36. Okay. Let's see, if I do 81 minus 108, that's negative 27. And negative 20 plus negative 27 plus 36, that looks like it's 9. And the units here, again, since it's a velocity, would be measured in meters per second. Okay. So what does this mean? What's the meaning of this? At exactly 3 seconds, the particle is traveling at a speed of 9 meters per second. And since this was positive, that means it's heading to the right. At exactly that time, that's how fast the particle is traveling. And since it's positive, it's going to the right. All right. So part C, it says find the acceleration of the particle at 1 second. So what it's asking for, it's asking for a of 1. Now before I can find a of 1, I have to figure out what a of t is. How do I find a of t? A of t is the acceleration, is the derivative of velocity. Well, here's my equation for velocity. So I have to take the derivative. So the derivative of the first term would be 3 times 3 is 9, t squared, minus 12 times 2 is 24. Reduce the power by 1. All right, derivative of 12t is just 12. So there's the equation for acceleration. There's the acceleration function. I'm trying to figure out what a of 1 is. Everywhere I see a t, I'm going to plug in 1. 9 times 1 squared minus 24 times 1 plus 12. 1 squared is 1, times 9 is 9, 24 times 1 is 24. Okay, so I'll get that. All right, 9 plus 12 is 21, minus 24 is negative 3, and the units would be meters per second per second. So that's my answer there. Part D, at what values of time does the particle change direction? So what does that mean? It goes from the right to the left, or goes from the left to the right. And it gives a reason for your answer. So let's first find at what times is the particle stopped. So what does that mean? When is the velocity 0? So let's go back to the velocity equation. Here was our velocity equation right here in red, right there. So let's set that equal to 0. Okay, and then let's do some factoring. Look at each term. It looks like I can take a 3t out. And if I take a 3t out, I would get t squared minus 4t plus 4. And if I do some more factoring, this actually factors into t minus 2 times another t minus 2. So if I look at each one of these things, and I can put a parenthesis around that as well, 3 times what would give me 0? 0. What number minus 2 would give me 0? 2. What number minus 2 would give me 0? 2 again. I don't need to rewrite it. So on my number line, these are the times when the velocity equals 0. So now let's put that on a number line. And technically we start our time at 0. So here's times. Let's figure out the signs of the velocity. Okay, so pick a number bigger than 2. And maybe like 3. If I put 3 in here, 3 times 3, that would be a positive. 3 minus 2, that would be a positive. Another 3 minus 2, that's another positive. So positive times positive times positive. That's a positive. So from 2 to infinity, the object has positive velocity, which means it's traveling to the right. I'll pick a number between 0 and 2. 1. I've put in a 1 here. 3 times 1, that's a positive. 1 minus 2, that's a negative. Another 1 minus 2, that's another negative. A positive times a negative is a positive, which means the object is traveling to the right. So what happens to this particle? From 0 to 2 seconds, the particle moves right, and then it momentarily stops, and then it heads right again. So if it goes right, stops for a second, and goes right some more, does it ever change directions? No, it does not. We can say the particle never changes directions because the velocity never changes signs. Now, part E, is the particle speeding up or slowing down at that time? Well, from our number line above, we just figured out that the velocity at 1 second was going to be positive. Okay, it's greater than 0. Now let's figure out what A of 1 is. We actually already found that in part C above. We figured out that that was -3, which is a negative number. V of 1 is positive, but A of 1 is negative. So at this time, velocity and acceleration have opposite signs. So that means the particle is actually slowing down. Because, and here's your justification, because V of 1 and A of 1 have opposite signs. So if you're traveling positive, that means the particle is moving to the right, but if your acceleration is negative, that means that even though it's going to the right, it's braking. That would be the meaning of it. If that's positive and that's negative, that means it's braking. So that right there is the note card. Now on the packet this evening, for your homework, okay, don't forget to go back and finish up the last packet where you're able to answer questions after you do note card 20. Okay, so there's just more practice here on position, velocity, and acceleration. Okay, so just try these problems. There's several free response problems, old free response problems. Okay. So I know it's kind of a bigger packet. Now some of these you might not be able to fit all your work on the actual packet itself. So just do those on notebook paper and staple it to your packet when you turn it in. Okay. So a lot of practice. Okay, a lot of practice. Now, these are, when you get to this point, these are former multiple choice questions from former exams. So even though I want you to pick the right answer, I want to see all your work. So please make sure you show all your work. And if you don't have enough room to show your work there, you can do it on the back of that sheet or on a piece of paper. But make sure you show your work and you show your logic, okay, to get full credit. So that's going to do it for this note card. Again, this was note card 20, titled Acceleration. Thank you for watching.